Okay, let's first try to understand what this problem is asking us to do. We have a circuit here, right? And it wants us to sketch IL of t. So we have some voltage, right? It's a voltage source, and because of that, there's going to be some current flow. This thing is going to get charged, right? So we want to find how much charge it's getting, right? How much current is flowing into it over time. So as you can see, the voltage turns on and then it turns off. So in this time, what happens to the current? Well, obviously the current is going to grow, right? But by how much? That's what we have to find out. So what equation do we know that applies for the voltage of an inductor? And you'll see why we're using the voltage equation, but here, let me just write it down first. Okay, cool. So we have this equation, right? Voltage of the inductor is equal to the inductance times the derivative of the current, right? Now, I know what you're thinking. Oh, this is in derivative form. We need to find the I, so we need to take an integral. We don't need to do that. And I'll explain why. Let's first think about what this means, all right? This means the change in I over the change in t, right? It's rise over run, right? It's basically a slope form equation, right? And we know most of these numbers. So here, let's plug in the stuff we know. So the voltage is going to be what? 10, right? So in this time, the voltage is going to be 10. So we can just plug in 10 over here. We know the inductance. What's the inductance? 4 microhenries, right? Now we just need to know what di dt is. But here's the thing. We're drawing a graph. And if we have all these other numbers stay constant, then it's going to grow at a linear rate, right? Here's what I mean. So first of all, what we want to see, how much did I change in how much time, right? How much time are we giving it? 0.1 seconds, right? So let's put that on the bottom. So what is the change of I over 0? Oh, whoops. What is the change of I over 0.1 seconds? So now we have our numbers. We can just solve for that change in I, right? We can, multiply both sides by 0.1. And then we can divide both sides by 4 microohms. 4 microhenries. And now what you'll realize is we get our change in I over these seconds. Again, after this, the voltage is 0. Before this, the voltage is 0. So there's not going to be a change in I, right? This is just going to zero out, which is going to zero out all of this. But in that time when voltage is 10, we can find how much I changed. And in this case, you solve this, what you end up getting is that it changed by 0.25 amps, right? So we know that starting here, because there was no voltage or anything, we can just draw a straight line here, right? Nothing changed. Then we get voltage, so it went up by 0.25 amps. Now, where is that on this graph? It's not defined. We can put it anywhere. The solution's put it here, so I'm just going to also put it here. And then obviously after that, the current doesn't change either, so we just draw a straight line, and we just label that 0.25 amps, right? You could also just go down and label the rest of the ticks if you wanted, but I'm pretty sure that's all you need for this question. And yeah, so then we know that at the time, right, that it's asking us at 0.1, it is 0.25 amps. Yeah.